Imagina por un momento una especie humana que convivió con nuestros antepasados, poderosa, diferente y llena de misterios aún sin resolver. Los neandertales no fueron solo una rama extinguida, sino auténticas maravillas extrañas de la naturaleza, músculos imponentes, fuerza extraordinaria y una capacidad asombrosa para adaptarse al hielo y a los entornos más hostiles. Pero detrás de su aspecto rudo existía inteligencia, emociones e incluso creatividad. ¿Quiénes eran realmente? ¿Y qué los hizo tan especiales como para que la humanidad moderna no pueda dejar de fascinarse con ellos? Durante cientos de miles de años, reinaron en Europa, prosperando en paisajes que nos matarían en días, cazando bestias masivas con nada más que lanzas de madera y su poder puro. No eran solo otra especie humana, eran auténticas rarezas de la naturaleza, los neandertales. Así que, si estas historias te son útiles, suscríbete, comenta tu ubicación y también la hora. Me encanta ver la mezcla. Tuve a alguien de Helsinki y a alguien de Houston en el mismo video. Uno está en el mañana, el otro en el ayer, o algo así. ¿Crees que eres fuerte? No eres nada comparado con ellos. El neandertal promedio podría aplastarte la mano sin siquiera intentarlo. Sus huesos eran más gruesos, sus músculos más densos, su poder más allá de cualquier cosa que nosotros, los humanos modernos, pudiéramos comprender, y durante años pensamos que eran solo hombres de las cavernas primitivos, brutos encorvados que no podían igualar nuestra inteligencia o adaptabilidad, pero esa historia estaba equivocada, totalmente equivocada. Descubrimientos recientes han destrozado por completo todo lo que pensábamos saber sobre estos antiguos humanos. No solo eran físicamente superiores a nosotros en casi todos los sentidos, sino que sus cerebros eran más grandes que los nuestros. Crearon herramientas complejas, controlaron el fuego, crearon arte y sobrevivieron a condiciones extremas que diezmarían a las poblaciones humanas modernas. No solo estaban sobreviviendo, estaban prosperando en algunos de los entornos más duros que la Tierra ha producido. Entonces, ¿qué los hizo especímenes físicos tan extraordinarios? Y si eran tan notables, ¿por qué no siguen aquí? ¿Por qué desaparecieron mientras nosotros prosperábamos? Las respuestas desafiarán todo lo que crees saber sobre la evolución humana. La historia de los neandertales comienza hace unos 400.000 años, cuando una población de antiguos humanos se aisló en Europa durante un período glacial masivo. Aislados de otros grupos humanos en África, estos europeos comenzaron a evolucionar rasgos distintos que los harían perfectamente adecuados para las condiciones de la edad de hielo en Europa. Sus cuerpos se volvieron más robustos y poderosos, no porque fueran primitivos, sino porque se estaban convirtiendo en máquinas de supervivencia especializadas. Cuando miramos un esqueleto de neandertal, lo primero que salta a la vista es la pura robustez de sus huesos. Sus huesos eran significativamente más gruesos y densos que los nuestros. Un fémur de neandertal, ese es el hueso del muslo, podría resistir fuerzas que romperían la pierna de un humano moderno como una ramita. Sus brazos y piernas muestran masivos sitios de inserción muscular, áreas donde sus poderosos músculos se conectaban al hueso. Los científicos que estudian estos puntos de inserción pueden decir que los neandertales tenían bíceps, tríceps y músculos del antebrazo, tremendamente poderosos. Pero no es solo que fueran más fuertes, su cuerpo entero estaba construido de manera diferente. Tenían pechos en forma de barril que eran mucho más anchos que los nuestros, especialmente en la parte inferior de la caja torácica. Este torso expandido les dio pulmones más grandes y probablemente un sistema cardiovascular más eficiente, adaptaciones críticas para actividades de alta energía en ambientes fríos. Sus pelvis también eran más anchas, creando un centro de gravedad más bajo que los habría hecho increíblemente estables y poderosos. Cuando miras un cráneo de Neandertal, inmediatamente notas la masiva cresta superciliar sobre los ojos. Esto no era solo para lucirse. Esa proyección ósea ayudaba a sostener su cara más grande y proporcionaba una protección extra para sus ojos. Sus narices eran significativamente más grandes que las nuestras, con fosas nasales más anchas y un puente más pronunciado. Esto no era un rasgo aleatorio, era una adaptación sofisticada para la vida en el frío. Una nariz más grande con más superficie interna les permitía calentar y humidificar el aire helado antes de que llegara a sus pulmones. Esto prevenía el tipo de daño por frío que los humanos modernos sufrirían en condiciones similares sin ayuda tecnológica. Su estructura facial también presentaba senos paranasales más grandes, lo que ayudaba aún más a calentar el aire inhalado. Estas no eran características primitivas, eran adaptaciones avanzadas que permitían a los neandertales prosperar en entornos que matarían a la mayoría de los humanos modernos. Sus mandíbulas eran otra maravilla de la evolución. Los neandertales no tenían mentón. Su mandíbula simplemente se curvaba hacia atrás desde sus dientes, sin el punto que sobresale que tenemos nosotros, pero lo que les faltaba en mentones lo compensaban con la fuerza de su mandíbula. Sus mandíbulas eran más gruesas y fuertes que las nuestras, capaces de generar una fuerza de mordida tremenda. Los patrones de desgaste en sus dientes nos dicen que usaban frecuentemente sus bocas como una tercera mano, sosteniendo pieles de animales u otros materiales mientras trabajaban en ellos. Esos dientes también eran diferentes. Sus incisivos, los dientes frontales, eran más grandes y mostraban patrones de desgaste distintivos, a diferencia de cualquier cosa vista en los humanos modernos. Algunos investigadores creen que usaban regularmente sus dientes frontales para agarrar y tirar de pieles de animales al prepararlas para su uso, algo que ningún humano moderno podría hacer sin dañar rápidamente sus dientes. Todas estas diferencias anatómicas se suman a una conclusión. Los neandertales eran potencias. Pero, ¿cuán fuertes eran exactamente? Los científicos han utilizado los sitios de inserción muscular en los huesos de Neandertal para estimar su fuerza en comparación con los humanos modernos, y los resultados son asombrosos. El neandertal promedio probablemente tenía una fuerza en la parte superior del cuerpo, al menos una vez y media mayor que la de un hombre humano moderno típico. Algunas estimaciones sugieren que la fuerza de su brazo podría haber sido el doble que la de atletas modernos entrenados. Su fuerza de agarre habría estado fuera de las listas de nuestros estándares. Un hombre humano moderno típicamente tiene una fuerza de agarre de alrededor de 80 a 120 libras de presión. El neandertal promedio, probablemente más de 200 libras de fuerza aplastante en cada mano. Podrían haber aplastado fácilmente objetos que requerirían que los humanos modernos usaran herramientas. Este extraordinario poder físico no era solo para lucirse. Era esencial para su estrategia de supervivencia. A diferencia de los grupos humanos posteriores que desarrollaron armas de proyectil especializadas que podían matar a distancia, los neandertales eran cazadores de combate cuerpo a cuerpo. Fabricaban lanzas pesadas diseñadas no para ser lanzadas, sino para ser clavadas directamente en presas grandes y peligrosas a corta distancia. Solo piénsalo por un momento. Los neandertales cazaban animales como rinocerontes lanudos, osos de las cavernas y mamuts, bestias masivas que podrían matar fácilmente a un humano, y lo hacían de cerca y en persona. Esto no era porque no pudieran concebir mejores métodos de caza. Era una estrategia deliberada que jugaba con sus fortalezas físicas
y estaba perfectamente adaptada a los entornos donde vivían. La evidencia física de esta estrategia de caza de alto riesgo está escrita en sus huesos. Los esqueletos de Neandertal muestran patrones de lesión que se han comparado con los vistos en los jinetes de rodeo modernos. Tienen fracturas curadas distribuidas por todo su cuerpo, especialmente en la cabeza, el cuello y la parte superior del cuerpo. Exactamente el patrón que se esperaría de encuentros cercanos con grandes animales peligrosos. Un estudio encontró que alrededor del 80% de los adultos neandertales mostraban evidencia de al menos una lesión curada significativa. El ejemplo más famoso es el del viejo de la Chapelle aux Saints, un neandertal que vivió hasta los 40 años, anciano para los estándares del Paleolítico. Su esqueleto muestra múltiples lesiones curadas, incluyendo costillas rotas, un dedo del pie aplastado, daño en la rodilla y abscesos dentales. A pesar de estas lesiones, sobrevivió durante años después, lo que sugiere que su comunidad lo cuidó durante la recuperación. Este no era un mundo gentil en el que vivían, y sus cuerpos muestran que se enfrentaron a esa dureza de frente. Su fuerza y estrategia de caza eran solo una parte de lo que hacía a los neandertales excepcionales. Sus cuerpos también estaban perfectamente adaptados para sobrevivir al frío extremo de maneras que iban mucho más allá de tener solo narices más grandes. La proporción de todo su cuerpo era diferente a la nuestra de maneras que maximizaban la retención de calor. Los humanos modernos evolucionaron en África y tienen proporciones corporales adecuadas para la disipación de calor, extremidades largas con una alta relación de superficie a volumen que ayuda a liberar el exceso de calor. Los neandertales evolucionaron el tipo de cuerpo opuesto. Tenían extremidades más cortas y complexiones más robustas, reduciendo la superficie a través de la cual podían perder calor. Esto les dio un físico similar al de los humanos modernos, que viven en ambientes extremadamente fríos, como las poblaciones inuit tradicionales, pero aún más pronunciado. Esta adaptación al frío no se trataba solo de mantenerse cómodo, se trataba de supervivencia. Cuando las temperaturas cayeron en picado durante los periodos glaciales, los cuerpos musculosos y compactos de los neandertales habrían sido significativamente más eficientes en la retención de calor que los cuerpos de los humanos modernos. Esto significaba que podían sobrevivir con menos asistencia tecnológica, menos capas de ropa, menos combustible necesario para los incendios y menos comida necesaria para mantener la temperatura corporal. Hablando de comida, los neandertales necesitaban mucha. Sus poderosos músculos, cerebros más grandes y los ambientes fríos que habitaban requerían una tremenda ingesta calórica. Los científicos estiman que los neandertales habrían necesitado entre 3.500 y 5.000 calorías diarias, aproximadamente el doble de lo que consume un humano moderno, sedentario, y comparable a lo que comen los atletas olímpicos durante el entrenamiento. ¿De dónde venían todas estas calorías? Principalmente, venían de la carne. El análisis de isótopos de los huesos de Neandertal muestra que eran carnívoros de alto nivel, obteniendo la mayor parte de su proteína de grandes herbívoros como ciervos, bisontes, caballos salvajes e incluso rinocerontes lanudos y mamuts. En muchos lugares parecen haberse especializado en la caza de renos durante las migraciones estacionales, interceptando las manadas en puntos estratégicos del paisaje. Esto no significa que nunca comieran plantas. Estudios recientes de la placa dental de los dientes de Neandertal han revelado evidencia de varios alimentos vegetales, incluyendo granos, tubérculos e incluso plantas medicinales. Pero la imagen general que emerge es de una dieta fuertemente dominada por la carne, especialmente en las regiones del norte durante los periodos más fríos,
cuando los alimentos vegetales habrían sido escasos. Esta dieta rica en carne no era solo una elección, era una necesidad dictada por su entorno y metabolismo. El frío amargo de la Europa glacial significaba que los alimentos vegetales eran estacionales y limitados, mientras que los productos animales de alta energía, no solo carne muscular sino grasa, tuétano y vísceras, proporcionaban las calorías concentradas que los neandertales necesitaban para alimentar sus cuerpos robustos durante los duros inviernos. La forma en que consiguieron toda esta carne es un testimonio de sus extraordinarias capacidades físicas y destreza en la caza. La evidencia arqueológica de los sitios neandertales muestra que eran cazadores hábiles y estratégicos que podían derribar a los animales de presa más grandes y peligrosos de la Europa de la Edad de Hielo. En sitios de toda Europa, los arqueólogos han encontrado los restos descuartizados de todo, desde renos y caballos salvajes hasta rinocerontes lanudos e incluso mamuts jóvenes. La distribución de las marcas de corte en estos huesos muestra que los neandertales no solo estaban carroñando, estaban descomponiendo sistemáticamente los cadáveres completos, extrayendo no solo carne, sino valiosa grasa, tuétano y otros nutrientes. En algunos lugares, como el sitio de Morán en Francia, la evidencia sugiere que los neandertales se dedicaban a matanzas masivas de bisontes, conduciendo manadas a trampas naturales donde podían ser sacrificadas eficientemente. En la Côte de Saint-Brelé, en Jersey, una isla en el Canal de la Mancha, los arqueólogos encontraron evidencia de que los neandertales pueden haber conducido manadas de mamuts por acantilados como estrategia de caza. Pero estos no eran cazadores oportunistas simples. La evidencia muestra que entendían el comportamiento animal y planificaban sus cacerías cuidadosamente. En muchos sitios, los restos muestran un enfoque en animales adultos de edad óptima, los objetivos más peligrosos pero también los más nutritivos. Este tipo de estrategia de caza selectiva requería no solo poder físico, sino conocimiento sofisticado y planificación. Su tecnología de caza, aunque no tan diversa como la de los humanos posteriores, era notablemente efectiva para sus necesidades. Las lanzas de madera encontradas en Schöningen, en Alemania, que datan de hace unos 300.000 años, muestran que no eran palos toscos, sino armas cuidadosamente elaboradas. Las lanzas estaban hechas de madera de abeto, con el peso perfectamente equilibrado hacia el frente, similar a las jabalinas modernas. Las puntas se endurecían por un cuidadoso carbonizado, creando armas que podían penetrar las gruesas pieles de los animales grandes. Más sorprendente para muchos investigadores fue el descubrimiento de que los neandertales a veces usaban armas a distancia. En el sitio de Abri-du-Marais, en Francia, el análisis microscópico de puntas de piedra mostró daños por impacto y rastros de materiales de unión que sugieren que se usaron como puntas de proyectil, posiblemente para lanzas arrojadizas. Aunque no tan avanzadas como los arcos y los atlats de los humanos posteriores, estos hallazgos muestran que los neandertales no estaban limitados al combate cuerpo a cuerpo. Quizás lo más impresionante fue su dominio de la tecnología adhesiva. En múltiples sitios de toda Europa, los investigadores han encontrado evidencia de que los neandertales crearon adhesivos complejos utilizando alquitrán de corteza de abedul, un proceso que requiere un calentamiento cuidadosamente controlado para extraer la resina pegajosa sin quemarla. Usaron estos adhesivos para unir puntas de piedra a mangos de madera, creando herramientas compuestas más efectivas. El proceso de creación de alquitrán de corteza de abedul es tan complejo que algunos arqueólogos han intentado recrearlo utilizando solo tecnologías disponibles para los neandertales, con éxito limitado. Las exigencias físicas del estilo de vida neandertal dejaron su huella en sus esqueletos de otra manera, la asimetría. Estudios de los huesos del brazo de Neandertal muestran que típicamente tenían brazos derechos significativamente más fuertes que los izquierdos, un patrón consistente con la realización repetida de poderosos movimientos de empuje con la mano derecha. Esto encaja perfectamente con lo que sabemos sobre sus técnicas de caza y proporciona evidencia adicional de que su fuerza extraordinaria no era solo genética, se desarrollaba a través de una vida de intensa actividad física. No deberíamos pensar en los neandertales como simplemente versiones más fuertes de nosotros mismos. Toda su fisiología era diferente, adaptada para satisfacer las demandas de su estilo de vida y entorno. Es probable que la composición de sus fibras musculares difiriera de la nuestra, con una mayor proporción de fibras de contracción rápida que generan poder explosivo en lugar de resistencia. Sus tasas metabólicas eran más altas, sus sistemas cardiovasculares más eficientes en la entrega de oxígeno durante la actividad intensa, y sus cuerpos mejores para conservar el calor en condiciones frígidas. Estos no eran rasgos primitivos, eran adaptaciones especializadas que hicieron a los neandertales increíblemente exitosos en su nicho ecológico. Durante más de 300.000 años prosperaron en entornos que iban desde el Mediterráneo hasta el borde del Ártico, sobreviviendo a múltiples ciclos glaciales y rápidos cambios climáticos que habrían desafiado incluso a los humanos modernos, equipados tecnológicamente. Pero su destreza física no era lo único notable de ellos. Quizás el aspecto más sorprendente de la biología neandertal y el que ha obligado a los científicos a reconsiderar por completo nuestra visión de estos antiguos humanos fueron sus cerebros. Durante décadas, el consenso científico sostuvo que los neandertales eran intelectualmente inferiores a los humanos modernos. La forma distintiva de su cráneo, con su forma alargada y su pronunciada cresta superciliar, se tomó como evidencia de habilidades cognitivas primitivas. Pero a medida que se descubrieron y analizaron más cráneos de Neandertal completos, surgió un hecho sorprendente. Sus cerebros eran en realidad más grandes que los nuestros. El volumen cerebral promedio de un Neandertal era de alrededor de 1.600 centímetros cúbicos, en comparación con unos 1.400 centímetros cúbicos para los humanos modernos. Algunos especímenes de Neandertal tenían cerebros tan grandes como 1.740 centímetros cúbicos, mucho más allá del tamaño de incluso los cerebros humanos modernos más grandes. El tamaño del cerebro no lo es todo, por supuesto. La organización interna también importa, pero aquí de nuevo, los estudios detallados de las endocastas del cráneo de Neandertal, modelos del cerebro basados en la forma interna del cráneo, han revelado una sofisticación sorprendente. Si bien sus cerebros estaban organizados de manera algo diferente a los nuestros, con áreas relativamente más grandes dedicadas a la visión y el control corporal, todavía tenían lóbulos frontales bien desarrollados. Las áreas asociadas con la planificación, la toma de decisiones y la cognición social. Las implicaciones son claras. Los neandertales no eran cognitivamente inferiores a los humanos modernos. Eran simplemente diferentes. Sus cerebros estaban adaptados para los desafíos específicos de su estilo de vida y entorno, con capacidades mejoradas en áreas como la conciencia espacial, el procesamiento visual y el control motor, todas críticas para los cazadores que navegan por terrenos complejos y se enfrentan a presas peligrosas a corta distancia. Esta diferencia neural se extendió a sus capacidades sensoriales también. Estudios de cráneos de Neandertal
sugieren que tenían cuencas oculares más grandes que los humanos modernos, lo que potencialmente indica ojos más grandes y capacidades visuales mejoradas, particularmente en condiciones de poca luz. Esto habría sido una ventaja significativa para los cazadores en los bosques de Europa, especialmente durante los largos inviernos cuando la luz del día era limitada. Es probable que su sentido del olfato también fuera diferente.
La estructura de la cavidad nasal neandertal sugiere que pueden haber tenido un sentido del olfato más agudo que los humanos modernos. Otra ventaja para los cazadores que necesitaban rastrear presas y detectar peligros potenciales en su entorno. Incluso su audición puede haberse adaptado a su estilo de vida. Los estudios de los huesos del oído neandertal sugieren que pueden haber tenido capacidades auditivas diferentes a las de los humanos modernos, potencialmente con una sensibilidad mejorada a ciertos rangos de frecuencia que habrían sido útiles para detectar presas o comunicarse en entornos boscosos. Todas estas adaptaciones sensoriales pintan un cuadro no de brutos primitivos, sino de humanos altamente especializados, cuya biología entera estaba exquisitamente adaptada a las demandas de la vida, como cazadores de la edad de hielo en los bosques y estepas europeos. Y la evidencia de su sofisticación cognitiva va mucho más allá del simple tamaño de su cerebro. El registro arqueológico muestra que los neandertales se involucraron en comportamientos que alguna vez se pensó que eran exclusivos de los humanos modernos, comportamientos que requieren pensamiento abstracto, planificación y transmisión cultural. Controlaban el fuego no solo para calentarse, sino para cocinar, transformando alimentos duros y fibrosos en formas más digeribles y potencialmente desbloqueando más calorías de su dieta. Crearon herramientas complejas que requerían múltiples pasos para producir, incluyendo herramientas compuestas que combinaban diferentes materiales. Cuidaban a sus heridos y ancianos, como lo demuestran numerosos esqueletos con lesiones curadas que habrían requerido cuidados a largo plazo para sobrevivir. Lo más sorprendente para muchos investigadores, crearon arte y objetos simbólicos. En sitios de toda Europa, los arqueólogos han encontrado evidencia de expresión artística neandertal, pigmentos procesados para su uso como colorantes, cuentas de concha aparentemente utilizadas como adornos e incluso pinturas rupestres que son anteriores a la llegada de los humanos modernos a Europa. En la cueva de Bruniquel, en Francia, los arqueólogos descubrieron algo verdaderamente extraordinario: una estructura circular hecha de estalagmitas rotas ubicada en las profundidades de la cueva, donde no podía llegar la luz natural, datada hace 176.000 años, cuando solo los neandertales habitaban Europa. Esta estructura sugiere que se aventuraban en las profundidades de las cuevas, controlando el fuego para la iluminación y creando estructuras organizadas para propósitos sobre los que solo podemos conjeturar, quizás ritual, quizás social. Estas no eran las acciones de brutos simples, eran los comportamientos de seres complejos e inteligentes, con ricas vidas sociales y tradiciones culturales, y nos obligan a reconsiderar por completo nuestra comprensión de quiénes eran los neandertales. Entonces, si los neandertales eran tan físicamente poderosos, tan bien adaptados a su entorno y tan cognitivamente sofisticados, ¿por qué desaparecieron? ¿Por qué nuestros ancestros, con sus cuerpos más frágiles y cerebros de tamaño similar, sobrevivieron mientras los poderosos neandertales se desvanecieron? La respuesta no es simple, y los científicos todavía están debatiendo las causas exactas de la extinción neandertal, pero varios factores probablemente contribuyeron a su desaparición. Un factor clave fue el cambio climático. Hace unos 40.000 años,
Europa experimentó una serie de fluctuaciones climáticas rápidas y extremas conocidas como eventos de Heinrich. Estos repentinos fríos habrían alterado dramáticamente los ecosistemas de los que dependían los neandertales, lo que podría haber reducido las poblaciones de sus especies de presa preferidas y haber hecho más difícil de sostener su dieta rica en carne y alta en calorías. Otro factor fue la llegada de los humanos modernos a Europa, que comenzó hace unos 45.000 años. Estos recién llegados trajeron diferentes tecnologías, diferentes estrategias de caza y posiblemente diferentes estructuras sociales que pueden haberles dado ventajas competitivas en ciertos entornos. Hay poca evidencia de violencia directa entre neandertales y humanos modernos. No hay fosas comunes o esqueletos con lesiones por armas que sugieran guerra o genocidio, pero la competencia por los recursos, incluso la competencia pacífica, podría haber empujado lentamente a las poblaciones de Neandertal al declive. Las enfermedades también pueden haber jugado un papel. Los humanos modernos que migraban de África probablemente llevaban patógenos a los que los neandertales nunca habían estado expuestos y contra los que no tenían inmunidad. Estas enfermedades novedosas podrían haber devastado las poblaciones de Neandertal ya estresadas por el cambio climático y la competencia. Quizás lo más intrigante es que ahora sabemos que los neandertales no desaparecieron por completo. Los estudios genéticos de las poblaciones humanas modernas fuera de África revelan que la mayoría de nosotros llevamos entre el 1% y el 4% de ADN neandertal en nuestros genomas. Una clara evidencia de que nuestros ancestros no solo compitieron con los neandertales, se cruzaron con ellos. Este mestizaje sugiere que en lugar de ser reemplazados por completo, los neandertales pueden haber sido parcialmente absorbidos por la creciente población humana moderna. A medida que sus números disminuían debido al cambio climático y la competencia, los neandertales restantes pueden haberse unido cada vez más a los grupos de humanos modernos. Su distintivo linaje genético se diluyó gradualmente, pero nunca se perdió por completo. La historia de los neandertales no es, por lo tanto, simplemente una de fracaso y extinción. Es un relato complejo de adaptación, resiliencia y, en última instancia, transformación. Su poder físico y sus adaptaciones especializadas los hicieron extraordinariamente exitosos durante cientos de miles de años, mucho más tiempo de lo que nuestra especie ha existido, y elementos de su biología viven en muchos de nosotros hoy. Los neandertales no eran humanos fallidos o callejones sin salida evolutivos. Eran seres notables cuyas capacidades físicas y adaptaciones les permitieron prosperar en algunos de los entornos más duros de la Tierra. Su historia nos recuerda que hay muchas maneras de ser humano, muchos caminos que nuestra evolución podría haber tomado. Como hemos visto, los neandertales eran verdaderas rarezas físicas de la naturaleza. Sus huesos eran más fuertes, sus músculos más poderosos, sus cuerpos más resistentes al frío y a las lesiones de lo que los nuestros podrían ser jamás. Eran máquinas de supervivencia especializadas, perfectamente adaptadas a las demandas de la Europa de la Edad de Hielo. Pero su historia está lejos de ser completa. A medida que se realizan nuevos descubrimientos y se desarrollan nuevas técnicas analíticas, nuestra comprensión de estos notables humanos continúa evolucionando, y como veremos en la próxima parte de nuestra exploración, su destreza física fue igualada por habilidades cognitivas y tecnológicas que nos obligan a reconsiderar por completo quiénes eran y cómo vivían. La evidencia es clara. Los neandertales no eran brutos primitivos. Eran humanos sofisticados y poderosos
cuya biología y cultura estaban perfectamente adaptadas para sobrevivir y prosperar en los desafiantes entornos de la Europa de la Edad de Hielo. Su extraordinaria fuerza física era solo un aspecto de una adaptación compleja y exitosa que les permitió dominar Europa durante cientos de miles de años. En la próxima parte de nuestra exploración, profundizaremos en la mente neandertal, sus habilidades cognitivas, sus innovaciones tecnológicas y la evidencia de comportamientos sociales y culturales complejos que pintan una imagen muy diferente a la de los estereotipos de hombres de las cavernas gruñendo de la imaginación popular. Y descubriremos que en muchos sentidos no eran tan diferentes de nosotros después de todo. Hemos establecido que los neandertales eran potencias físicas, más fuertes, más robustos y perfectamente adaptados para sobrevivir en entornos frígidos que matarían a la mayoría de los humanos modernos en días. Pero su naturaleza extraordinaria va mucho más allá de la fuerza bruta. Sus cerebros y habilidades cognitivas desafían todo lo que pensábamos que sabíamos sobre estos antiguos humanos. Durante décadas, la narrativa científica retrató a los neandertales como intelectualmente inferiores a los humanos modernos, más grandes y más fuertes, sí, pero careciendo de la sofisticación mental que supuestamente permitió al Homo sapiens superarlos en la competencia. Esta historia conveniente posicionó a nuestros ancestros como los legítimos herederos del planeta, destinados a reemplazar a sus primos más primitivos a través de una inteligencia superior. Pero los descubrimientos recientes han demolido por completo este mito egocéntrico. Los neandertales no eran solo brutos musculosos, eran seres sofisticados con grandes cerebros, tecnología compleja y estructuras sociales que les permitieron prosperar durante cientos de miles de años en entornos en los que apenas podemos sobrevivir con toda nuestra tecnología moderna. Comencemos con el hecho más sorprendente. Los neandertales tenían cerebros más grandes que nosotros. El volumen cerebral promedio de un neandertal era de aproximadamente 1.600 centímetros cúbicos en comparación con unos 1.400 centímetros cúbicos para los humanos modernos. Algunos especímenes de neandertal tenían cerebros tan grandes como 1.700 centímetros cúbicos, mucho más allá del rango de incluso los cerebros humanos modernos más grandes. El tamaño no lo es todo cuando se trata de cerebros, por supuesto. La organización interna importa enormemente, y aquí es donde las cosas se ponen realmente interesantes. Estudios detallados de las endocastas del cráneo de Neandertal, modelos del cerebro basados en la forma interna del cráneo, revelan que estaban organizados de manera diferente a los nuestros, pero no de la manera que podrías esperar. Los neandertales tenían cortezas visuales proporcionalmente más grandes, las partes del cerebro responsables de procesar la información visual. Esta capacidad de procesamiento visual mejorada habría sido tremendamente ventajosa para los cazadores que operaban en los variados paisajes de la Europa de la Edad de Hielo, lo que les permitía detectar presas a mayores distancias y en condiciones de poca luz de lo que los humanos modernos podían lograr. También dedicaron más recursos neuronales al control corporal y al procesamiento somatosensorial, las partes del cerebro que gobiernan el movimiento y la sensación física. Esto tiene perfecto sentido dado su estilo de vida altamente físico y sus técnicas de caza que requerían un control preciso de movimientos poderosos. Lo fascinante es que cuando los investigadores tienen en cuenta estas diferencias en la organización cerebral, encuentran que las áreas cognitivas superiores restantes del cerebro neandertal eran comparables en tamaño a las de los humanos modernos. Sus lóbulos frontales, las partes del cerebro, asociadas con la planificación,
la toma de decisiones y la cognición social estaban bien desarrollados, lo que sugiere capacidades cognitivas similares a las nuestras. Pero la evidencia más convincente de la sofisticación cognitiva neandertal no proviene de la anatomía de su cerebro, sino de lo que realmente hicieron, el registro arqueológico de sus comportamientos y tecnologías. Y esta evidencia está obligando a los científicos a reconsiderar por completo quiénes eran estos antiguos humanos. Consideremos sus logros tecnológicos. Durante más de 150 años, la industria de herramientas de piedra musteriense, la tradición distintiva de fabricación de herramientas asociada con los neandertales, fue considerada relativamente simple y estática en comparación con las tecnologías en rápida evolución de los primeros humanos modernos. Pero un examen más llamadas telefónicas de voz más cercana revela un nivel de sofisticación que exige respeto. Los neandertales eran maestros de lo que se llama la técnica levalloise, un método de producción de herramientas de piedra que requiere una planificación cuidadosa y una ejecución precisa. La técnica implica preparar un núcleo de piedra de una manera específica para controlar la forma y el tamaño de las lascas resultantes, creando herramientas con formas predeterminadas perfectamente adecuadas para tareas específicas. Esto no es simplemente golpear rocas juntas, requiere pensamiento abstracto, la capacidad de búsquedas en la web, visualizar la herramienta terminada dentro de la piedra en bruto, y un control motor preciso para ejecutar los golpes necesarios. Los arqueólogos experimentales modernos que intentan recrear estas herramientas a menudo requieren años de práctica para alcanzar el nivel de habilidad evidente en incluso las herramientas neandertales promedio. Y su destreza tecnológica iba mucho más allá del simple tallado de piedra. En múltiples sitios de toda Europa, los arqueólogos han encontrado evidencia de que los neandertales crearon y usaron adhesivos complejos para unir puntas de piedra a mangos de madera, creando herramientas compuestas más efectivas. El adhesivo más común era el alquitrán de corteza de abedul, una sustancia que requiere un sofisticado proceso de producción de varias etapas. Para crear alquitrán de corteza de abedul, los neandertales tenían que calentar cuidadosamente la corteza de abedul en un ambiente con poco oxígeno a temperaturas controladas, demasiado frío, y el alquitrán no se formará, demasiado caliente, y simplemente se quemará. Este proceso requiere no solo control del fuego, sino una comprensión de la pirotecnología que alguna vez se pensó que era exclusiva de los humanos modernos. La complejidad de este proceso es tan grande que los arqueólogos modernos han luchado por recrearlo utilizando solo tecnologías disponibles para los neandertales. El hecho de que los neandertales produjeran rutinariamente estos adhesivos en toda Europa durante decenas de miles de años dice mucho sobre sus capacidades cognitivas y sus suscripciones de streaming de video, know-how tecnológico. Su dominio del fuego se extiende más allá de la producción de adhesivos. La evidencia de los sitios neandertales muestra que colocaban estratégicamente hogares dentro de sus espacios vitales. Controlaban las temperaturas del fuego para diferentes propósitos y probablemente usaban el fuego no solo para calentarse, sino para cocinar, endurecer herramientas de madera y posiblemente incluso para fines rituales. En el sitio de Abric Romani en España, los arqueólogos encontraron evidencia de múltiples hogares dispuestos en lo que parece ser un diseño terapia visual, con luces infrarrojas y rojas con propósito dentro de un espacio vital, lo que sugiere que los neandertales estaban organizando sus entornos de vida de formas complejas. Los hogares se colocaron para crear diferentes áreas de actividad, algunas para la fabricación de herramientas, otras para el procesamiento de alimentos, otras quizás para dormir. Su música instrumental de los 70 kit de herramientas no se limitaba a la piedra y la madera. En varios sitios, los arqueólogos han encontrado evidencia de herramientas de hueso, implementos terapia de luz LED azul para el acné elaborados a partir de huesos de animales que fueron, ajustes de audio para un receptor Marantz NR1200 en un cine en casa formados y pulidos para fines específicos. En Abri, Peroni y Peche de la Salle en Francia, los investigadores descubrieron herramientas de hueso neandertales llamadas lissoirs, implementos especializados utilizados para trabajar pieles de animales, haciéndolas más flexibles y resistentes al agua. Lo notable de estas herramientas es que representan la primera instancia documentada de una tecnología que más tarde se volvería común entre los humanos modernos. Este no es un caso de neandertales copiando tecnología humana moderna. Estas herramientas de hueso son anteriores a la llegada de los humanos modernos a la región en miles de años. Es un claro caso de invención independiente. Evidencia adicional de la sofisticación cognitiva neandertal y la innovación tecnológica. Aún más sorprendente fue el descubrimiento en 2020 de evidencia directa de tecnología de fibra utilizada por los neandertales. En el sitio de Abri-du-Marat, en Francia, los investigadores encontraron un fragmento de cordón de 3 capas hecho de fibras de corteza interna, que data de hace entre 41 y 52.000 años, la evidencia directa más antigua de fabricación de cuerdas o cordones jamás descubierta. La importancia de este hallazgo no puede ser exagerada. La creación de cordones de fibra, sistemas de audio multizona trenzada, requiere la comprensión de múltiples conceptos. ¿Cómo los materiales pueden ser procesados para extraer fibras utilizables? ¿Cómo esas fibras pueden ser retorcidas para crear hebras más fuertes? ¿Y cómo esas hebras pueden ser combinadas para crear un cordón aún más fuerte? Implica una comprensión matemática de patrones y procesos que alguna vez se pensó que era únicamente humana. Y el cordón no es solo significativo como una tecnología en sí misma. Es la base de numerosas otras tecnologías. Cuerdas, redes, bolsas, ropa, componentes de refugios. Todo depende de la capacidad de crear y usar cordones. La presencia de esta tecnología sugiere que los neandertales pueden haber tenido acceso a toda una gama de herramientas y equipos complejos que simplemente no se han conservado en el registro arqueológico. Durante mucho tiempo hemos sabido que los neandertales eran cazadores expertos, pero la investigación reciente ha revelado cuán sofisticadas eran sus estrategias de caza. Lejos de ser simples depredadores oportunistas o cazadores simples que tomaban cualquier presa que encontraran, los neandertales empleaban tácticas de caza planificadas y complejas que requerían un conocimiento íntimo del comportamiento animal y las características del paisaje en sitios de toda Europa. La evidencia muestra que los neandertales se posicionaban estratégicamente para interceptar manadas migratorias en cuellos de botella naturales en el paisaje, lugares donde el terreno concentraría a los animales y los haría más vulnerables. Parece que coordinaban cacerías en grupo, con diferentes individuos desempeñando diferentes roles en la persecución y el derribo de presas peligrosas. Algunos sitios sugieren que empleaban técnicas de caza por acoso, donde grupos de cazadores trabajaban juntos para líneas de altavoces Wharfdale canalizar animales hacia puntos de emboscada o trampas naturales como barrancos o áreas pantanosas. Este tipo de caza coordinada requiere no solo destreza física, sino comunicación, planificación y conocimiento compartido, tanto del terreno como del comportamiento de las especies de presa. La sofisticación de su caza se refleja en su selección de presas. Los estudios de los restos de animales de los sitios neandertales muestran que no solo tomaban cualquier animal que encontraban, estaban seleccionando animales adultos de edad óptima, los que estaban en su mejor momento físico, que proporcionarían el mayor beneficio nutricional, a pesar de ser los más peligrosos de cazar. Este tipo de caza selectiva no es el comportamiento de brutos de mente simple. Refleja una toma de decisiones compleja que sopesa los riesgos contra los beneficios y requiere un rendimiento del receptor Marantz SR715 en cine, en caza extenso, transmitido a través de generaciones. Es el comportamiento de cazadores-recolectores sofisticados con ricas tradiciones culturales y una profunda comprensión ecológica. Su conocimiento ecológico se extendía más allá de la caza. El análisis de los restos de plantas y los residuos de los sitios neandertales muestra que explotaban una amplia gama de recursos vegetales para alimentos, medicinas y materiales. No eran solo comedores de carne, sino recolectores, sistemas de altavoces de cine en casa con subwoofer activos de conocimiento que entendían qué plantas eran comestibles, cuáles tenían propiedades medicinales y cuáles podían usarse para fines tecnológicos. En el sitio de la cueva Shanidar en Irak, los científicos encontraron concentraciones de polen alrededor de un entierro neandertal que sugieren que se pueden haber colocado flores con el cuerpo. Si bien la interpretación del entierro de flores ha sido debatida, la presencia de estos restos de plantas demuestra que los neandertales interactuaban con las plantas de formas complejas más allá de la simple subsistencia básica. Más convincente es la evidencia del cálculo dental, la placa endurecida en los dientes de Neandertal. El análisis de este material ha revelado rastros de numerosas especies de plantas, incluidas algunas con propiedades medicinales. Un ejemplo, particularmente rendimiento del amplificador Marantz PM8006, en un sistema de altavoces BMW 702, S3 sorprendente proviene de la cueva. El Cidrón en España, donde los investigadores encontraron evidencia de que un neandertal con un absceso dental parece haber estado consumiendo plantas con propiedades antibióticas, lo que sugiere que entendían no solo qué plantas eran comestibles, sino cuáles podían usarse para tratar dolencias específicas. Este tipo de conocimiento etnobotánico sofisticado, la comprensión de qué plantas se pueden usar para qué sistemas de audio inalámbricos de cine en casa fines, requiere no solo aprendizaje individual, sino transmisión cultural a través de generaciones. Es otra línea de evidencia que apunta a sociedades neandertales complejas con conocimiento y tradiciones acumulados. Quizás el aspecto más sorprendente y controvertido del comportamiento neandertal es su aparente capacidad para la expresión simbólica, el arte, los adornos y las prácticas potencialmente rituales, que alguna vez se pensó que eran rasgos exclusivamente humanos. Durante décadas, el consenso científico sostuvo que el comportamiento simbólico emergió repentinamente con los humanos modernos, lo que representa un salto cognitivo que nos separó de todos los demás homininos. Pero la evidencia de los sitios neandertales está desafiando esta narrativa. En múltiples sitios de toda Europa, los arqueólogos han encontrado evidencia de que los neandertales recolectaban y procesaban pigmentos de colores como el ocre rojo y amarillo. Estos materiales no tenían un uso práctico obvio, pero pueden haberse usado para la decoración corporal, para dar color a las pieles de animales o para crear símbolos visuales. En la cueva de los aviones en España, los investigadores encontraron conchas marinas perforadas manchadas con pigmentos que parecen haber sido usadas como adornos, que datan de hace más de 115.000 años. mucho antes de que los humanos modernos llegaran a la región. Hallazgos similares de otros sitios sugieren que esto no fue un ajuste de sonido para un amplificador Marantz NR1200 en un sistema de cine en casa con altavoces Polk aislado, sino una práctica neandertal, puntos de venta de Marantz en Los Ángeles generalizada, aún más sistemas de sonido para teatro en casa y TV con subwoofer activo asombroso, es la evidencia del arte rupestre neandertal. En la cueva de la Pasiega en España, un símbolo en forma de escalera pintado en ocre rojo ha sido datado hace más de 64.000 años, al menos 20.000 años antes de que los humanos modernos llegaran a Europa. Se han obtenido fechas similares para estarcidos de manos en la cueva de Maltravieso y un símbolo geométrico rojo en la cueva de Ardales, ambos en España. Si estas fechas son precisas y siguen siendo controvertidas entre algunos investigadores, proporcionan evidencia clara de que los neandertales estaban creando representaciones simbólicas mucho antes de que se encontraran con los humanos modernos. Esto sería una refutación dramática de la idea de que el pensamiento simbólico era único para el Homo sapiens. Menos controvertida, pero igualmente significativa, es la evidencia de construcciones neandertales en las profundidades de los sistemas de cuevas. En la cueva de Bruniquel en Francia, los arqueólogos descubrieron una estructura circular hecha de estalagmitas deliberadamente rotas, ubicada a más de 300 metros de la entrada de la cueva, en completa oscuridad. Esta estructura ha sido datada hace 176.000 años, cuando solo los neandertales habitaban Europa. Las implicaciones son profundas. La creación de esta estructura habría requerido no solo planificación y cooperación, sino luz artificial. Los neandertales habrían tenido que mantener y controlar el fuego mientras se aventuraban en las profundidades de la cueva, y el propósito de la estructura sigue siendo misterioso. No muestra evidencia de habitación o uso práctico, lo que sugiere que puede haber tenido un significado ritual o simbólico. Estas no son las acciones de brutos simples e impulsados por el instinto. Son los comportamientos de seres con ricas vidas interiores, seres capaces de pensamiento abstracto, representación simbólica y prácticas potencialmente espirituales o ritualistas. Quizás el aspecto más humanizador del comportamiento neandertal es su aparente cuidado mutuo. Se han encontrado múltiples esqueletos de neandertal con evidencia de lesiones graves y discapacidades que se habían curado antes de la muerte, individuos que solo pudieron haber sobrevivido con el apoyo y el cuidado de su comunidad. El famoso viejo de la Chapelle aux Saints es un ejemplo clásico. Este neandertal anciano tenía artritis severa, una cadera dañada, dientes faltantes y otras patologías que le habrían dificultado contribuir a la caza u otras tareas físicamente exigentes. Sin embargo, sobrevivió hasta una edad que era avanzada para los estándares del Paleolítico, lo que sugiere que su comunidad continuó cuidándolo a pesar de su productividad limitada. Se han encontrado casos similares en otros sitios, individuos con lesiones graves o deformidades congénitas que sobrevivieron durante años después de quedar sistemas de altavoces de cine en casa y audio discapacitados. Este no es el comportamiento de criaturas preocupadas solo por la supervivencia inmediata. Es evidencia de lazos sociales, compasión y un reconocimiento del valor de los individuos más allá de su utilidad inmediata, rasgos esencialmente humanos. Y luego están los entierros. En múltiples sitios de Europa y Oriente Medio, los arqueólogos han encontrado restos de neandertal en posiciones y contextos que sugieren fuertemente un entierro intencional. Los cuerpos se colocaron en depresiones naturales o creadas artificialmente, a veces en posiciones flexionadas y ocasionalmente con lo que parecen ser ajuares funerarios, objetos colocados con el difunto. En la cueva Shanidar en Irak, se han descubierto varios entierros neandertales, incluido el famoso entierro de flores mencionado anteriormente. Si bien la interpretación de que las flores fueron colocadas deliberadamente con el cuerpo sigue siendo controvertida, el entierro deliberado en sí mismo no está en duda. Excavaciones más recientes en la Chapelle aux Sables en Francia Han. Líneas de altavoces. Bowers and Wilkins epoch strengthened the case for Neanderthal burials. A careful re-examination of the site has revealed clear evidence of a deliberately dug pit in which the body was placed, not simply a natural depression, as some skeptics had suggested. Intentional burial of the dead implies not just practical concerns about hygiene or predators, but conceptual thinking about death, possibly beliefs about an afterlife, and certainly emotional attachments to deceased community members. It's one of the clearest indicators that Neanderthals possessed a mental and emotional life comparable to our own. All of this evidence, from their technology to their art, from their ecological knowledge to their care for the injured, paints a picture of Neanderthals as sophisticated beings with rich cultural traditions and complex social lives. They weren't lesser versions of us. They were a different expression of humanity, adapted to different circumstances, but no less intelligent or capable. So if they were so capable, why did they disappear while our ancestors thrived? The answer is complex and still debated, but it likely involves a combination of factors rather than any single decisive advantage possessed by modern humans. Climate change clearly played a role. Around 40,000 years ago, Europe experienced a series of rapid, severe climate fluctuations, sudden cold snaps followed by brief warming periods. These dramatic shifts would have stressed the ecosystems Neanderthals relied on, potentially reducing prey populations and making their high-calorie, meat-dependent diet more difficult to maintain. Modern humans, with their slightly different technological toolkit and potentially more flexible subsistence strategies, may have been better equipped to weather these changes. Evidence suggests early modern humans exploited a broader range of food resources, including small game and aquatic foods that appear less frequently in Neanderthal sites. But it wasn't just about technology or subsistence. Demographic factors likely played a crucial role. Genetic studies of Neanderthal remains suggest they maintained relatively small, isolated populations with limited genetic diversity. This would have made them vulnerable to inbreeding, depression, reduced fitness due to the accumulation of harmful genetic variants. Modern humans, in contrast, appear to have maintained larger, more connected population networks, with more genetic mixing between groups. This demographic structure would have provided greater resilience in the face of environmental challenges and potential competitive advantages in resource-rich areas. Disease may have been another factor. Modern humans migrating from Africa would have carried pathogens that Neanderthals had never been exposed to and had no immunity against. These novel diseases could have had devastating effects on Neanderthal populations already stressed by climate change and competition. And competition, while perhaps not taking the form of direct violence, was likely significant. As modern human populations expanded into Europe, they would have increasingly competed with Neanderthals for key resources, prime hunting territories, sheltered cave sites, high-quality stone for tools. Even without conflict, this competition could have slowly pushed Neanderthal populations into decline. But perhaps the most intriguing aspect of the Neanderthal disappearance is that they didn't completely vanish. Genetic studies have revealed that most people of Eurasian descent carry between 1 and 4% Neanderthal DNA in their genomes. Clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. This interbreeding suggests that rather than being completely replaced, Neanderthals may have been partially absorbed into the expanding modern human population. As their numbers dwindled due to the factors discussed above, the remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted but never completely lost. The genetic legacy of these interbreeding events remains with us today. Some Neanderthal gene variants appear to have been advantageous for modern humans moving into the colder environments of Eurasia. Genes involved in skin and hair characteristics, fat metabolism, and immune responses to European pathogens. These beneficial variants were retained by natural selection and remain part of our genetic makeup. Other Neanderthal variants were apparently detrimental and were gradually purged from the human genome. These include genes on the X chromosome, suggesting male hybrid offspring may have had reduced fertility, and genes involved in certain aspects of brain development. This selective retention and elimination of Neanderthal DNA has shaped the human genome in complex ways that we're only beginning to understand. So the story of the Neanderthals isn't simply one of inferior beings replaced by superior ones. It's a complex tale of two human species, both highly intelligent, both capable of remarkable technological and cultural achievements, facing the challenges of a rapidly changing world with different biological and cultural adaptations. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who thrived in some of the most challenging environments on Earth for hundreds of thousands of years, far longer than our species has existed. Their physical and cognitive adaptations allowed them to dominate Ice Age Europe in ways we can barely imagine, and elements of their biology live on in many of us today. As we continue to discover more about these extraordinary beings, our appreciation for their capabilities only grows. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more nuanced and respectful understanding of who the Neanderthals really were. They weren't just freaks of nature in terms of their physical strength. They were sophisticated, intelligent beings with rich cultural traditions, complex technologies, and social lives not so different from our own. Their story isn't a sidebar in human evolution. It's a parallel narrative of a different but equally valid way of being human. And as we'll explore in the next part of our journey, the Neanderthals' remarkable adaptations extended far beyond their bodies and brains to encompass complex social structures and cultural innovations that allowed them to thrive in environments we can barely survive in today. Their story continues to unfold as new discoveries reveal more about these extraordinary humans who walked alongside our ancestors through the Ice Age landscapes of ancient Europe. We've explored the extraordinary physical prowess of Neanderthals, their immense strength, cold, adapted bodies, and specialized hunting capabilities. We've examined their remarkable brains and cognitive abilities, larger than our own, organized differently, but clearly capable of sophisticated thought and innovation. Now let's delve even deeper into what truly made Neanderthals such remarkable beings, their social structures, survival strategies, and the astonishing technologies they developed to thrive in the harshest environments Earth has ever produced. Imagine yourself transported back 40,000 years to the depths of the last ice age in Europe. You're standing on a windswept plain in what will someday become southern France. The temperature hovers around -20 degrees Celsius. The wind cuts like a knife. The landscape is a treeless steppe stretching to the horizon, broken only by the occasional rocky outcrop. There are no buildings, no roads, no power lines. Nothing of the modern world exists. Just you, the cold, and the unforgiving wilderness. Without modern technology, without Gore-Tex jackets, insulated boots, GPS devices, and emergency services, how long would you survive? Hours, perhaps a day or two at most. This was the world of the Neanderthals, not just for a weekend camping trip or a survival challenge, but for their entire lives, generation after generation, for hundreds of thousands of years. And they didn't just survive in these conditions. They thrived. They hunted. They raised families. They created art and technology. They lived full, complex lives in environments that would kill most modern humans within days. How did they do it? The answer lies not just in their physical adaptations, though those were certainly crucial, but in their social structures, their accumulated knowledge, and the sophisticated technologies they developed. Technologies that have only recently begun to receive the recognition they deserve. Let's start with their living spaces. The popular image of Neanderthals as cave dwellers isn't entirely wrong. They did frequently use caves and rock shelters as bases, especially in colder regions and during winter months. But archaeological evidence shows they were far more sophisticated in their use of these spaces than previously thought. At sites across Europe, archaeologists have found evidence of structured living areas within caves, spaces organized for different activities, with hearths strategically placed for warmth, cooking, and light. At a brick Romany in Spain, researchers discovered the remains of wooden platforms that appear to have been used as sleeping areas, raised off the cold, damp cave floor. These weren't just random nests, they were deliberately constructed fixtures within a well-organized living space. But Neanderthals weren't confined to caves. At open-air sites like Moldova in Ukraine, archaeologists have found evidence of constructed dwellings, structures built using mammoth bones as foundations and supports, likely covered with hides to create sheltered living spaces, even in areas without natural caves. These structures weren't temporary overnight shelters. They show evidence of repeated use and maintenance over time. What's particularly impressive about these living spaces is the evidence they provide for long-term planning and resource management. Neanderthals weren't just reacting to immediate needs, they were anticipating future requirements and preparing accordingly. They stockpiled materials for fires, gathered tools and resources, and created spaces that could support extended periods of occupation during the harshest seasons. This kind of foresight extends to their food acquisition strategies as well. Far from being opportunistic scavengers or simple hunters, taking whatever prey they happened to encounter, Neanderthals employed sophisticated strategies that required intimate knowledge of animal behavior and landscape features. Studies of animal remains from Neanderthal sites reveal patterns that speak to highly organized hunting practices. At many sites, the bones show a focus on specific prey species during particular seasons: reindeer during autumn migrations, ibex during summer months when they descended to lower elevations, bison when they congregated in valleys during winter. This selective hunting required not just tracking skills, but an understanding of animal migration patterns and seasonal behaviors. The evidence also shows they were transporting specific parts of animals back to their living sites, the most nutritionally valuable portions that provided the highest return for the energy expended in carrying them. This kind of selective transport isn't random or instinctive. It reflects calculated decisions about resource efficiency. Another sign of sophisticated planning and knowledge. Perhaps most impressive is the evidence for communal hunting techniques. At sites like Le Côte de Saint-Brelé in Jersey, an island in the English Channel, archaeologists found the remains of dozens of mammoths and rhinoceroses at the base of a cliff. The pattern of these remains suggests Neanderthals were driving herds toward the cliff edge, causing them to fall to their deaths, a hunting technique that would have required coordination among multiple individuals playing different roles. Similar evidence for cooperative hunting has been found at sites across Europe. These weren't solitary hunters, but coordinated groups working together to take down prey that no individual could handle alone. This kind of cooperation required communication, planning, and social bonds, all hallmarks of complex social structures, and these social structures extended beyond just hunting parties. Multiple lines of evidence suggest Neanderthals lived in small, close-knit groups with strong social bonds and mutual support systems. The care for injured individuals discussed earlier, those who survived serious injuries that would have prevented them from contributing to hunting or other physically demanding tasks, demonstrate social commitments that transcended immediate utility. The size of these groups has been estimated based on the dimensions of living spaces and resource availability in different environments. In most regions, Neanderthals appear to have lived in bands of perhaps 10 to 20 individuals, extended family groups that stayed together year-round, sharing resources and knowledge. These bands weren't completely isolated, however. The distribution of distinctive stone tools and raw materials suggests networks of interaction between different Neanderthal groups across substantial distances. High-quality stone was sometimes transported or traded over distances of 50 kilometers or more, indicating contact and exchange between different bands. Within these groups, there's evidence for division of labor and specialized roles. Patterns of wear and injury on Neanderthal skeletons suggest some individuals consistently performed certain tasks. Some focused more on hunting, others perhaps on processing hides or creating tools. This kind of specialization allows groups to accomplish more than if everyone were a generalist, and it's another indicator of social complexity. There's even tantalizing evidence for distinct cultural traditions among different Neanderthal groups, regional variations in tool-making techniques, resource exploitation strategies, and possibly symbolic practices. These weren't just instinctive behaviors shared by all members of the species, but learned traditions passed down through generations within specific communities. This cultural transmission, the passing of knowledge from one generation to the next, is perhaps one of the most distinctively human aspects of Neanderthal life. The complexity of their technologies and hunting strategies couldn't have been reinvented by each individual or even each generation. They represent accumulated knowledge built up over thousands of years and preserved through teaching and learning within social groups. Consider their technological achievements. The sophistication of Neanderthal stone tools has long been recognized, but recent research has revealed they were capable of much more than just knapping flint. They created composite tools, implements combining different materials like stone, wood, and adhesives to create more effective weapons and tools than could be made from any single material. The production of birch bark tar adhesive mentioned earlier is particularly impressive. Creating this substance requires a complex multi-stage process, involving the careful application of heat in a low oxygen environment. The tar must then be processed and applied while still warm to cool, and it becomes brittle and unusable. This technology requires not just knowledge of materials, but precise control of temperature and timing. Experimental archaeologists have attempted to recreate this process, using only technologies available to Neanderthals with limited success. The fact that Neanderthals routinely produced these adhesives across Europe for tens of thousands of years speaks volumes about their technological sophistication and the depth of their cultural knowledge. They weren't just making tools, they were engaging in complex manufacturing processes that required planning, precision, and specialized knowledge. This isn't the behavior of simple brutes acting on instinct. It's the work of intelligent beings with rich cultural traditions and accumulated technical expertise. Their technological prowess extended to fibers and cordage as well. The discovery of a 3-ply cord fragment at Abri-du-Marat in France, mentioned earlier, indicates they understood how to process plant materials to extract usable fibers, how to twist those fibers to create stronger strands, and how to combine those strands to create even more robust cord. This might seem like a simple technology to modernize, but it represents a fundamental innovation that underlies countless other technologies. Cordage is the foundation for nets, bags, snares, fishing lines, and components of complex tools like bows. It's a transformative technology that vastly expands what humans can accomplish, and Neanderthals mastered it tens of thousands of years ago. The evidence for fiber technology raises intriguing questions about what other perishable technologies Neanderthals might have developed. Did they create basketry, woven mats, nets for fishing or trapping small game? The cordage fragments suggest these possibilities, though direct evidence is scarce due to the poor preservation of organic materials in most archaeological contexts. We do know they processed animal hides to create what were likely clothing and shelter components. At multiple Neanderthal sites, archaeologists have found specialized tools used for scraping and softening hides, indicating not just the use of animal skins for practical purposes, but a sophisticated understanding of how to transform raw hides into more useful materials. The bone tools discovered at Abri-Peyroni and Pêche de Lazay in France, the lissoirs or smoothers used for working hides, represent another level of technological refinement. These weren't simply stones picked up and used opportunistically, but carefully crafted implements designed for specific tasks. Their creation required selecting appropriate bones, shaping them to the desired form, and polishing them to create the smooth working surface necessary for effectively processing hides. This kind of specialized tool creation suggests not just technical knowledge, but specialized roles within Neanderthal societies. Individuals who developed particular skills and perhaps focused on specific tasks. It's another indicator of social complexity and division of labor within their communities. Fire technology was another area where Neanderthals demonstrated remarkable sophistication. They weren't just using naturally occurring fires started by lightning strikes. They were creating and controlling fire for multiple purposes. Hearths found at Neanderthal sites show evidence of repeated use and maintenance, with different areas seemingly designated for different fire-related activities. They appear to have used fire not just for warmth and cooking, but for hardening wooden tools, processing birch bark tar, and potentially for ritual or social purposes. The structures found deep within Brunicle Cave could only have been created with artificial light, indicating Neanderthals were able to transport and maintain fire even in challenging environments. The mastery of fire represents a transformative technology that dramatically expands what humans can accomplish. It extends the habitable day by providing light after sunset, allows for the occupation of colder environments by providing warmth, makes a wider range of foods digestible through cooking, and serves as a tool for transforming materials like wood and adhesives. Neanderthals weren't just using fire,
they were exploiting its full potential as a multi-purpose technology. Their technological achievements weren't limited to material culture. They also developed sophisticated hunting and tracking techniques that allowed them to effectively exploit the challenging environments of Ice Age Europe. The evidence suggests they understood animal migration patterns, recognized seasonal changes in prey behavior, and strategically positioned themselves to intercept prey at vulnerable points in the landscape. They appear to have employed ambush hunting techniques, drive hunting strategies, and possibly trapping methods, each requiring different skills and knowledge. This wasn't instinctive behavior, but learned expertise, accumulated and refined over generations, and passed down through teaching and observation. The variety of hunting techniques employed by Neanderthals suggests they were adapting their strategies to specific prey species and environmental conditions, not simply applying a one-size-fits-all approach. This kind of context-specific adaptation requires not just knowledge, but the ability to analyze situations and apply appropriate techniques, clear evidence of higher cognitive abilities. Their knowledge extended beyond hunting to broader ecological understanding. Analysis of plant remains from Neanderthal sites indicates they were exploiting a wide range of plant resources for food, medicine, and materials. They weren't just meat eaters, but knowledgeable foragers who understood which plants were edible, which had medicinal properties, and which could be used for technological purposes. The evidence from El Sidrón cave in Spain, where dental calculus from a Neanderthal with a dental abscess contained traces of plants with antibiotic properties, suggests they understood not just which plants were edible, but which could be used to treat specific ailments. This kind of medicinal knowledge represents another sophisticated cultural tradition that would have been built up over generations and passed down through social learning. All of these technological and knowledge systems, from tool making to fire control, from hunting techniques to medicinal practices, represent cultural adaptations that allowed Neanderthals to thrive in environments that would quickly kill most modern humans without technological assistance. They weren't just surviving through physical adaptations, but through the accumulated wisdom of countless generations, preserved and transmitted through social learning. This brings us to perhaps the most fascinating aspect of Neanderthal life, their apparent capacity for symbolic thought and expression. For decades, the scientific consensus held that symbolic behavior, art, ritual, ornaments, and other non-utilitarian expressions emerged suddenly with modern humans and represented a cognitive leap that separated us from all other hominins. But evidence from Neanderthal sites is challenging this narrative. The perforated and pigment-stained seashells from Cueva de los Aviones in Spain, dating to over 115,000 years ago, suggest Neanderthals were creating and wearing ornaments long before modern humans arrived in Europe. These weren't practical tools, but items of personal decoration, objects that likely held symbolic meaning within Neanderthal social context. The red ochre paintings in Spanish caves, the ladder-like symbol at La Pasiega, the hand stencils at Maltravieso, the geometric pattern at Ardales, dated to more than 64,000 years ago, suggest Neanderthals were creating visual symbols millennia before modern humans reached these regions. If these dates are accurate, and they remain controversial among some researchers, they provide compelling evidence that symbolic expression wasn't unique to Homo sapiens, but was within the cognitive capabilities of Neanderthals as well. The circular structure deep within Bruniquel Cave, created 176,000 years ago, represents perhaps the most enigmatic evidence for symbolic behavior. This arrangement of broken stalagmites, located far from the cave entrance in complete darkness,
shows no evidence of practical use. It appears to have been created for purposes that transcended immediate utility, perhaps ritual, perhaps social, but clearly symbolic in nature. These aren't isolated findings, but part of a growing body of evidence suggesting Neanderthals possessed what might be called a symbolic mind, the capacity to assign meaning to objects and actions beyond their immediate practical value. This capacity underlies not just art and ornaments, but potentially language, ritual, and other complex social behaviors that we consider quintessentially human. The question of whether Neanderthals had language remains one of the most intriguing and challenging aspects of research into these ancient humans. Direct evidence is scarce. Language leaves no fossils, but multiple lines of indirect evidence suggest they likely possessed complex communication systems. The anatomy of the Neanderthal vocal tract, reconstructed from fossil remains, indicates they were physically capable of producing a range of sounds similar to modern human speech. The hyoid bone, a small bone in the throat that supports the tongue and is crucial for speech production, from a Neanderthal at Kabara Cave in Israel, is virtually identical to that of modern humans. Genetic evidence is also suggestive. Neanderthals possessed the FOXP2 gene, often called the language gene, because mutations in this gene cause severe speech and language disorders in modern humans. The Neanderthal version of this gene was very similar to our own, suggesting they may have had similar language capabilities. But perhaps the most compelling evidence comes from the complexity of their social behaviors and technologies. The coordination required for cooperative hunting, the teaching necessary to transmit complex technological knowledge like birch bark, tar production, the apparent division of labor within social groups. All these behaviors would be extremely difficult to accomplish without complex communication systems. Language isn't just about the physical ability to produce sounds. It's about the cognitive capacity to use symbols to represent concepts and to combine those symbols according to consistent rules. The evidence for symbolic thought in other domains, art, ornaments, possibly ritual, suggests Neanderthals possessed the cognitive foundations for language use. If they did have language, what might it have been like? We can only speculate, but given their environment and lifestyle, Neanderthal language might have been rich in terminology related to hunting, animal behavior, weather patterns, and landscape features. It might have included sophisticated ways to communicate about past events and future plans, essential for coordinating hunting strategies and seasonal movements. It likely included social language, ways to express relationships, emotions, and group identity. This brings us to another fascinating aspect of Neanderthal life: their emotional and spiritual worlds. The evidence for intentional burial of the dead discussed earlier suggests they had concepts about death and perhaps beliefs about an afterlife. The care for injured individuals indicates strong social bonds and empathy. The possible ritual structures, like the one at Brunikel Cave, suggest they may have had spiritual or religious concepts. These aren't the behaviors of simplistic beings concerned only with immediate survival needs. They suggest Neanderthals had rich inner lives, that they thought about abstract concepts, formed deep emotional attachments, and perhaps contemplated questions about existence and meaning in ways not dissimilar to our own. Recent genetic research has provided intriguing hints about Neanderthal psychology. Studies of Neanderthal DNA suggest they may have had a greater tendency toward depression and mood disorders. Compared to modern humans, potentially an adaptation to the long, dark winters of Northern Europe, where conserving energy through reduced activity during the harshest season might have been advantageous. Other genetic evidence suggests potential differences in social behavior. Neanderthals appear to have had smaller, more tightly knit social groups than early modern humans. This social structure may have been an adaptation to the environments they inhabited, where resources were often sparse and widely scattered, making large group living impractical. These smaller, more intimate social groups might have fostered intense bonds between individuals, but potentially limited the scale of cooperation and information sharing, compared to the larger networks maintained by early modern humans. This difference in social structure, not any deficit in individual cognitive capacity, may help explain some of the differences in cultural development between the two species. The picture that emerges from all this evidence is of Neanderthals as sophisticated beings with complex social lives, rich cultural traditions, and cognitive capabilities not fundamentally different from our own. They weren't lesser versions of us, but a different expression of humanity, adapted to different environments and circumstances, but no less intelligent or capable. Their physical adaptations, the powerful bodies, the cold, adapted physiology, the enhanced visual systems, were matched by equally impressive cultural adaptations. They developed technologies perfectly suited to their needs, accumulated knowledge about their environments that allowed them to exploit resources efficiently, and created social structures that supported their lifestyle in some of the most challenging environments on Earth. For hundreds of thousands of years, far longer than our species has existed, they thrived across Europe and parts of Asia. They weathered multiple glacial cycles, survived dramatic climate shifts, and developed cultural traditions that were passed down through countless generations. Their success wasn't accidental or temporary. It was the result of sophisticated adaptations, both biological and cultural. So why did they disappear while our ancestors thrived? As discussed earlier, the answer likely involves multiple factors: climate change, competition with expanding modern human populations, possibly disease, and demographic challenges related to their small, isolated population structure. But their disappearance doesn't invalidate their achievements or diminish their significance in the story of human evolution. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who dominated Ice Age Europe for hundreds of millennia, and whose genetic legacy lives on in many of us today. Perhaps the most important lesson from our growing understanding of Neanderthals is that there are many ways to be human, many paths that our evolution might have taken. The Neanderthals represent an alternative expression of humanity, different from us in important ways, but equally valid, equally sophisticated, and equally worthy of our respect and admiration. They weren't just freaks of nature in terms of their physical strength. They were extraordinary beings in every sense, physically, cognitively, technologically, and culturally. Their story isn't a sidebar in human evolution, but a parallel narrative of a different but equally valid way of being human. And as we'll explore in the next part of our journey, the relationship between Neanderthals and our direct ancestors, the early modern humans who expanded out of Africa around 60,000 years ago, is far more complex and intriguing than the simple tale of replacement that dominated scientific thinking for decades. The evidence suggests not just competition, but interaction, admixture, and potentially cultural exchange, a fascinating chapter in the human story that continues to unfold as new discoveries are made. What's clear is that Neanderthals weren't just strong, they were sophisticated. They weren't just survivors, they were innovators. And they weren't failed humans. They were successful, intelligent beings who thrived in environments we can barely survive in today. Their story deserves to be told not as a footnote in human evolution, but as a remarkable chapter in its own right. The tale of another kind of human who walked the earth alongside our ancestors, and whose legacy lives on in our genes and in our growing appreciation for the diversity of human experience. We've journeyed deep into the world of Neandertals, exploring their extraordinary physical capabilities, their sophisticated minds, and the complex cultural adaptations that allowed them to thrive in the harshest environments of Ice Age Europe. But their story becomes even more fascinating when we examine their interactions with our direct ancestors, the anatomically modern humans who began migrating out of Africa around 70,000 years ago, and eventually reached Europe around 45,000 years ago. The traditional narrative of this encounter was simple and dramatic. Superior modern humans, armed with more advanced technology and greater intelligence, rapidly replaced the primitive Neanderthals through competition for resources or even direct conflict. It was a compelling story that positioned our ancestors as the inevitable victors in an evolutionary contest. But like so many simple narratives about complex historical processes, it was fundamentally wrong. The real story, revealed through decades of archaeological research and recently transformed by genetic discoveries, is far more nuanced and intriguing. It isn't a tale of superior beings replacing inferior ones, but of two highly adapted human species, each with their own strengths and specialized adaptations, encountering one another after hundreds of thousands of years of separate evolution. To understand this encounter, we need to first understand who these early modern humans were. Our direct ancestors who had evolved in Africa, while Neanderthals were adapting to the harsh conditions of Ice Age Europe. Anatomically modern humans, Homo sapiens, emerged in Africa around 300,000 years ago, while Neanderthals were developing stockier, more powerful bodies adapted to cold environments. Our ancestors were evolving in the varied environments of Africa, from savannas to forests, from highlands to coastal regions. This diverse ecological background may help explain some of the differences between the species. Modern humans developed more gracile bodies, taller, lighter, with longer limbs and less muscle mass than Neanderthals. These proportions were better suited to heat dissipation in warm climates, and may have provided greater endurance at the expense of raw power. Where Neanderthals were sprint specialists, modern humans were marathon runners, capable of persistence hunting that involved tracking prey over long distances until the animals collapsed from exhaustion. Their technology reflected these differences. Where Neanderthals excelled at creating heavy thrusting spears for close quarters hunting, early modern humans developed projectile weapons, lightweight spears that could be thrown from a distance, and eventually atlatls, spear throwers, that extended their throwing range even further. These technologies minimize the risk of injury from dangerous prey and match the more gracile, endurance-oriented physique of modern humans. By around 70,000 years ago, groups of modern humans began expanding beyond Africa, moving first into the Middle East, and then gradually spreading across Asia, reaching Australia by about 65,000 years ago. Their expansion wasn't a single, coordinated migration, but a series of movements by different groups over thousands of years. When they reached Europe around 45,000 years ago, they encountered landscapes and conditions very different from their African homeland. Europe was in the grip of the last ice age, with environments ranging from cold steppes in the north to Mediterranean woodlands in the south. And inhabiting these challenging landscapes were the Neanderthals, humans whose bodies and cultures had been adapting to these conditions for hundreds of thousands of years. What happened when these two human species met? For decades, the archaeological records seemed to tell a simple story. Modern humans appeared in Europe, and within a few thousand years, Neanderthals disappeared. This apparent correlation led many researchers to conclude that modern humans had simply outcompeted Neanderthals, perhaps due to superior technology, greater intelligence, or more efficient subsistence strategies. But recent discoveries have revealed a much more complex picture. The first bombshell came in 2010, when genetic researchers announced they had sequenced the Neanderthal genome and made a startling discovery. Most people of Eurasian descent carry between 1 and 4% Neanderthal DNA in their genomes. This was clear evidence that our ancestors didn't just compete with Neanderthals, they interbred with them. Subsequent genetic studies have refined our understanding of this interbreeding. It appears to have occurred multiple times between 45 and 55,000 years ago, primarily in the Middle East, but potentially in Europe as well. The pattern of Neanderthal DNA in modern human genomes suggests the interbreeding wasn't just rare, isolated events, but occurred with sufficient frequency to leave a lasting genetic legacy. This discovery fundamentally changed our understanding of the relationship between modern humans and Neanderthals. It wasn't a simple case of one species replacing another, but a complex process involving both competition and intermixing. Neanderthals didn't simply go extinct in a very real sense. Aspects of them live on in many of us today. The genetic evidence also revealed something fascinating about the nature of this interbreeding. Certain types of Neanderthal DNA were retained in the modern human genome, while others were selectively removed over generations. This suggests some Neanderthal gene variants provided advantages to modern humans adapting to Eurasian environments, while others were neutral or detrimental. Among the beneficial Neanderthal genes that many modern humans still carry are variants related to skin and hair characteristics that may have helped modern humans adapt to northern latitudes with less sunlight. Genes involved in fat metabolism that could have aided survival in colder climates, and immune system genes that may have provided resistance to pathogens prevalent in Eurasia but not in Africa. On the other hand, there's a notable scarcity of Neanderthal DNA on the X chromosome and in genes related to male fertility, suggesting male hybrids may have had reduced fertility, a common pattern in hybridization between closely related species. There also appears to have been selection against Neanderthal variants of certain genes involved in brain development, though the implications of this remain unclear. The interbreeding between Neanderthals and modern humans wasn't just a biological process. It must have involved social interactions as well. We can only speculate about the nature of these encounters, but they clearly involve sufficient social integration for mating and reproduction to occur. Did Neanderthal individuals join modern human groups? Did modern humans join Neanderthal bands? Were there mixed communities where both species lived together? The archaeological record provides tantalizing hints, but few definitive answers. What's clear is that the boundary between the two species was permeable enough for significant genetic exchange to occur. This genetic evidence has forced a fundamental reconsideration of the relationship between modern humans and Neanderthals. Rather than a simple replacement, it now appears to have been a complex process involving both competition and assimilation. As modern human populations expanded and Neanderthal populations declined, likely due to a combination of climate change, competition, and possibly disease, the remaining Neanderthals may have increasingly joined modern human groups, their distinctive genetic lineage gradually becoming diluted, but never completely lost. The archaeological evidence for interaction between the two species is more ambiguous, but nonetheless intriguing. In several regions of Europe, particularly France and northern Spain,
archaeologists have identified cultural traditions that appear to blend elements of Neanderthal and modern human technologies. The most famous of these is the Chartel-Perronian industry, a tool-making tradition found in central France and northern Spain, dating to around 40 to 45,000 years ago. Chartel-Perronian tools combine elements typical of Neanderthal Mousterian technology with features more characteristic of the early modern human Aurignacian industry, particularly the production of blade tools and bone implements. For years, archaeologists debated whether the Chartel-Perronian represented Neanderthals adopting aspects of modern human technology through cultural contact, or modern humans incorporating elements of Neanderthal technology into their own traditions. The discovery of Neanderthal remains in clear association with Chartel-Perronian tools at the site of Arty-sur-Cure in France, seem to settle the question in favor of the former interpretation. These were Neanderthals adopting aspects of modern human technology. But recent redating of some key sites has complicated this picture. It now appears that in some regions the Chartel-Perronian may have developed before modern humans arrived in the area, suggesting independent innovation by Neanderthals rather than borrowing from newcomers. In other regions, the chronological overlap between the two species is clearer, making cultural exchange more plausible. Whatever the exact mechanisms, it's clear that the relationship between Neanderthals and modern humans wasn't simply one of competition and replacement. There was interaction, genetic exchange, and potentially cultural transmission in both directions. The old narrative of superior modern humans replacing primitive Neanderthals has given way to a much more nuanced understanding of a complex encounter between two highly adapted human species. This revised understanding of the Neanderthal-modern human relationship raises fascinating questions about the nature of cognitive and cultural differences between the two species. If Neanderthals were capable of interbreeding with modern humans, adopting or independently inventing similar technologies, and potentially exchanging cultural knowledge, how different were they really? The genetic evidence suggests the two species diverged from a common ancestor between 500 and 700,000 years ago. This is a significant period of separate evolution, enough time for substantial biological differences to develop, as evidenced by the distinct physical characteristics of Neanderthals and modern humans. But it's important to remember that for most of this time, both species were developing as intelligent cultural beings within the genus Homo. The differences between Neanderthals and modern humans are better understood not as differences in fundamental cognitive capacity, but as differences in specialized adaptations to distinct environments and lifestyles. Neanderthals weren't less intelligent than modern humans. They were differently intelligent, their cognitive abilities shaped by the specific challenges of life as Ice Age hunters in Europe. This perspective helps explain both the impressive achievements of Neanderthal culture, their sophisticated technologies, their successful adaptation to harsh environments, their apparent capacity for symbolic expression, and the differences between their cultural trajectory and that of modern humans. Modern humans, evolving in the more diverse environments of Africa, may have developed greater cultural flexibility, an ability to rapidly adapt their behaviors and technologies to new circumstances. This flexibility would have been advantageous as they expanded into new environments across Asia, Australia, and eventually Europe. It's not that they were smarter than Neanderthals, but that their cognitive adaptations were suited to a more mobile, exploratory lifestyle. Neanderthals, in contrast, appear to have developed deep, specialized knowledge adapted to specific European environments. Their technologies and subsistence strategies were highly effective for the conditions they faced, but may have been less adaptable to rapid environmental change. Again, this doesn't reflect lesser intelligence, but a different adaptive strategy, depth of knowledge rather than breadth. These different cognitive adaptations may help explain why modern humans were ultimately more successful in the face of the rapid climate fluctuations that characterize the period between 40,000 and 30,000 years ago. As conditions changed, modern humans may have been able to adjust their behaviors and technologies more quickly, while Neanderthals' specialized adaptations became less viable. The social structures of the two species likely differed as well, with important implications for their interaction. Genetic evidence suggests Neanderthals lived in relatively small, isolated groups with limited interaction between communities. This social structure would have been well suited to environments where resources were scattered and populations needed to be widely distributed, but it may have limited the exchange of innovations and made them vulnerable to localized extinction events. Modern humans, in contrast, appear to have maintained larger, more connected population networks, with more genetic mixing between groups. This social structure would have facilitated the spread of innovations, provided buffers against local resource shortages, and potentially given them a demographic advantage when the two species came into competition. These differences in social structure may have played a crucial role in the ultimate fate of the Neanderthals. As climate fluctuations stressed local ecosystems and modern humans expanded into Neanderthal territories, the more connected modern human populations may have been better able to withstand these pressures than the relatively isolated Neanderthal bands. It's important to note that none of these differences imply modern humans were inherently superior to Neanderthals. Both species had developed highly successful adaptations to their respective environments. Neanderthals thrived in Ice Age Europe for hundreds of thousands of years, far longer than our species has existed. Their eventual disappearance wasn't due to any intrinsic deficiency, but to a complex interplay of factors, including climate change, competition, and demographic challenges. The timing of Neanderthal disappearance varied across Europe, with the latest convincing evidence coming from sites in Gibraltar, dated to around 40,000 years ago, and possibly as late as 37,000 years ago in isolated pockets of Iberia. This gradual contraction of their range, rather than a sudden continent-wide extinction, is consistent with a complex process involving multiple factors rather than a single decisive cause. Climate change clearly played a role. The period between 40,000 and 30,000 years ago saw dramatic climate fluctuations, including several severe cold episodes known as Heinrich events. These sudden cooling periods would have stressed the ecosystems Neanderthals relied on, potentially reducing the populations of their preferred prey species and making their high-calorie, meat-heavy diet more difficult to sustain. Modern humans, with their slightly different technological toolkit and potentially more flexible subsistence strategies, may have been better equipped to weather these changes. Evidence suggests early modern humans exploited a broader range of food resources, including small game and aquatic foods that appear less frequently in Neanderthal sites. But it wasn't just about technology or subsistence. Demographic factors likely played a crucial role. Genetic studies of Neanderthal remains suggest they maintained relatively small, isolated populations with limited genetic diversity. This would have made them vulnerable to inbreeding, depression, reduced fitness due to the accumulation of harmful genetic variants. A fascinating study published in 2019
used computer modeling to examine whether demographic factors alone could have led to Neanderthal extinction. The researchers found that even without climate change or competition, the small population size of Neanderthals and their vulnerability to inbreeding depression could have led to their disappearance. Add in the stresses of climate fluctuations and competition with expanding modern human populations, and their fate becomes more understandable. The most likely scenario is that all these factors, climate change, competition, demographic challenges, and possibly disease, interacted in complex ways that varied across different regions of Europe. In some areas, climate change may have been the primary driver of Neanderthal decline. In others, direct competition with modern humans may have played a larger role. And throughout the process, the small, isolated nature of Neanderthal populations would have made them increasingly vulnerable to local extinction events. As Neanderthal populations dwindled, the remaining individuals may have increasingly joined modern human groups, a process suggested by the genetic evidence for interbreeding. This wouldn't have been a simple, one-way assimilation, however. The modern humans who encountered Neanderthals would have had much to learn from these highly adapted residents of Ice Age Europe. Neanderthals had accumulated generations of knowledge about European environments, which plants were edible or medicinal, how to track and hunt the local prey species, where to find essential resources like water and stone for tools. Modern humans, as newcomers to these landscapes, would have enormously benefited from this local knowledge. It's intriguing to consider what other aspects of Neanderthal culture might have been transmitted to modern humans during this period of contact. Did modern humans learn hunting techniques from Neanderthals? Did they adopt aspects of Neanderthal technology, like the production of birch bark tar adhesives? Did they incorporate Neanderthal medicinal practices or spiritual beliefs into their own cultural traditions? The archaeological record provides few clear answers, but the possibility of such cultural exchange adds another fascinating dimension to the story of the encounter between these two human species. It wasn't simply modern humans replacing Neanderthals, but a complex process of interaction that potentially involved both genetic and cultural exchange. This revised understanding of the Neanderthal-modern human relationship has profound implications for how we think about human evolution and diversity. It challenges the linear, progressive view that has dominated much of paleoanthropology, the idea that evolution produced a series of increasingly advanced human species, culminating in Homo sapiens as the pinnacle of the process. Instead, it suggests a more complex branching pattern, where different human species evolved in parallel, each developing specialized adaptations to particular environments and lifestyles. Neanderthals weren't a stepping stone on the path to modern humans, but a distinct branch of humanity with their own unique evolutionary trajectory. This perspective aligns with what we now know about other members of the human family tree. The discovery of Homo floresiensis, the so-called hobbits of Indonesia, and Homo luzonensis in the Philippines reveals that multiple human species existed alongside our own until relatively recently, and the identification of the denisovanos, another distinct human species that interbred with both Neanderthals and modern humans, further complicates the picture. Far from being the linear march of progress depicted in those familiar textbook illustrations, human evolution was a complex bush with multiple branches developing in parallel, sometimes interacting and hybridizing, sometimes competing, but each representing a valid and successful adaptation to particular circumstances. The Neanderthals weren't failed humans or evolutionary dead ends. They were remarkably successful beings who thrived in challenging environments,
for hundreds of thousands of years through a combination of biological and cultural adaptations. Their physical power, those extraordinarily strong bodies that have been the focus of much of our exploration, was just one aspect of a complex and sophisticated adaptation to life in Ice Age Europe. Their legacy lives on not just in the DNA many of us carry, but in our growing appreciation for the diversity of human experience and the many ways to be human. The story of the Neanderthals reminds us that our species' current dominance of the planet isn't the inevitable result of inherent superiority, but the outcome of a complex historical process involving both chance and adaptation. And it raises profound questions about human identity and uniqueness. If another human species existed alongside our own until relatively recently, a species with comparable cognitive capabilities, complex cultural traditions, and the ability to interbreed with us, what does that say about our place in nature? What might our world be like if Neanderthals had survived to the present day? These questions take on added significance as we consider the possibility of encountering non-human intelligence in the future, whether through artificial intelligence or potential contact with extraterrestrial beings. Our experience with Neanderthals suggests that intelligence and complexity can take different forms, and that our human-centric perspective may limit our ability to recognize and appreciate these differences. The Neanderthals, with their powerful bodies, sophisticated minds, and complex cultural adaptations, represent both a mirror and a window. A mirror reflecting aspects of ourselves that we share with these ancient relatives, and a window into alternative possibilities for being human. Their story isn't just about who they were, but about who we are and who we might have been under different circumstances. As we continue to uncover new evidence about these remarkable beings, our understanding of them grows ever richer and more nuanced. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more respectful appreciation of Neanderthals as sophisticated, intelligent beings with rich cultural traditions and complex social lives. They weren't just freaks of nature in terms of their physical strength. They were extraordinary beings in every sense, whose story continues to fascinate and inform our understanding of what it means to be human. And as we'll explore in the final part of our journey, the legacy of the Neanderthals extends far beyond their physical disappearance, influencing not just our biology through the genes we inherited from them, but our understanding of ourselves and our place in the natural world. Throughout our exploration of Neanderthals, we've discovered that these ancient humans were truly extraordinary beings, not just in terms of their remarkable physical strength, but in their cognitive abilities, technological innovations, and social complexity. Far from being the primitive cavemen of popular imagination, they were sophisticated humans perfectly adapted to the harsh environments of Ice Age Europe. But perhaps the most surprising aspect of the Neanderthal story is how their legacy continues to influence us today, not just through the genes many of us carry, but through what their existence reveals about human nature and the course of our evolution. In this final chapter, we'll explore the lasting impact of Neanderthals on our biology, our self-understanding, and our vision of humanity's past and future. Let's begin with their most direct legacy, the Neanderthal DNA that lives on in many modern humans. When researchers first sequenced the Neanderthal genome in 2010, they made the startling discovery that most people of Eurasian descent carry between 1% and 4% Neanderthal DNA in their genomes. This was conclusive evidence that our ancestors didn't simply replace Neanderthals, they interbred with them, and we carry the genetic legacy of those encounters.
Subsequent research has revealed the complex pattern of this genetic inheritance. Not all Neanderthal genes were equally likely to be retained in the modern human genome. Some appear to have been advantageous and were favored by natural selection, while others were gradually eliminated from our gene pool. Among the beneficial Neanderthal genes that many modern humans still carry are variants related to skin and hair characteristics that may have helped our ancestors adapt to northern latitudes with less sunlight. Neanderthals had been living in these environments for hundreds of thousands of years before modern humans arrived, and they had developed genetic adaptations to cope with the reduced UV exposure. Adaptations that proved beneficial to modern humans moving into similar environments. Other retained Neanderthal genes are involved in fat metabolism and may have helped modern humans adapt to colder climates, where efficient energy storage and utilization were crucial for survival. Still others affect immune function, potentially providing resistance to pathogens prevalent in Eurasia, but not in Africa, giving modern humans a survival advantage as they expanded into new territories. The distribution of Neanderthal DNA in modern populations tells an intriguing story about human migrations and interactions. People of East Asian descent typically carry slightly more Neanderthal DNA than Europeans, suggesting multiple episodes of interbreeding as modern humans spread across Eurasia. Indigenous populations in sub-Saharan Africa, whose ancestors didn't migrate through Eurasia, have little to no Neanderthal DNA, a pattern that perfectly matches what we would expect if interbreeding occurred primarily after modern humans left Africa. Some Neanderthal gene variants appear to influence traits that go far beyond simple physical adaptations. Certain Neanderthal genes have been linked to aspects of neurological function, immune response, and even mood regulation. One fascinating example is a Neanderthal variant that affects the risk of depression, potentially representing an adaptation to the long, dark winters of Northern Europe, where reducing activity during the harshest season might have been advantageous. Other Neanderthal variants have been associated with conditions like Crohn's disease, type 2 diabetes, and even susceptibility to certain viral infections, including, intriguingly, severe COVID-19. The relationship between these genetic variants and disease risk is complex. What might have been adaptive in the Paleolithic environment may have different effects in our modern world, with its dramatically different diet, lifestyle, and disease exposure. The pattern of Neanderthal genes that weren't retained in the modern human genome is equally revealing. There's a notable scarcity of Neanderthal DNA on the X chromosome, and in genes related to male fertility, suggesting male hybrids may have had reduced fertility, a common pattern in hybridization between closely related species. This reduced male fertility may help explain why the overall percentage of Neanderthal DNA in modern humans remains relatively low despite evidence for multiple interbreeding events. There also appears to have been selection against Neanderthal variants of certain genes involved in brain development. The implications of this pattern remain unclear. It could reflect incompatibilities between Neanderthal and modern human neural development, or it might simply be the result of random evolutionary processes unrelated to cognitive function. What's clear is that we are, in a very real sense, part Neanderthal. Their genetic legacy lives on in most non-African populations, influencing various aspects of our biology in ways we're only beginning to understand. This biological connection to these ancient relatives forces us to reconsider the traditional narrative of human origins and the relationship between different human species.
But the legacy of Neanderthals extends far beyond just the genes they contributed to our DNA. Their very existence and our growing understanding of their sophisticated nature has fundamentally changed how we think about human evolution and diversity. For much of the 20th century, human evolution was portrayed as a linear progression from primitive, ape-like ancestors to increasingly advanced forms culminating in Homo sapiens as the pinnacle of the process. Neanderthals were positioned as a side branch, an evolutionary dead end that couldn't compete with our supposedly superior species. This linear, progressive view of human evolution reflected the cultural biases of the time more than the actual evidence. It positioned modern humans, particularly Europeans, who were doing most of the research, as the inevitable winners of an evolutionary contest, justifying their global dominance as the natural outcome of superior capabilities. The revised understanding of Neanderthals that has emerged in recent decades completely undermines this self-serving narrative. Neanderthals weren't primitive or less evolved. They were highly adapted humans whose physical and cultural characteristics reflected hundreds of thousands of years of successful evolution in specific environments. They weren't an evolutionary dead end, but a remarkably successful branch of humanity that thrived for far longer than our species has existed. This perspective aligns with what we now know about human evolution more broadly. Rather than a linear march of progress, the evidence reveals a complex bush with multiple branches developing in parallel, each representing successful adaptations to particular circumstances. Modern humans aren't the culmination of this process, but simply the last surviving twig on a once much more diverse human family tree. This revised understanding has profound implications for how we think about human identity and uniqueness. If another human species existed alongside our own, until relatively recently, a species with comparable cognitive capabilities, complex cultural traditions, and the ability to interbreed with us, what does that say about our place in nature? What makes us human may not be unique to Homo sapiens, but shared across multiple species within the genus Homo. The Neanderthal story also challenges our assumptions about progress and adaptation. Their disappearance wasn't because they were somehow less advanced or capable than modern humans. It was the result of a complex interplay of factors including climate change, demographic challenges, and the specific historical circumstances of their encounter with our ancestors. Had circumstances been different? Had the climate been more stable? Had modern humans arrived in Europe at a different time? Had Neanderthal populations been larger or more connected, the outcome might have been different. We might today live in a world where Neanderthals still existed as a distinct population, or where hybridization had proceeded further, creating a more even genetic blend of the two species. These counterfactual scenarios aren't just idle speculation. They highlight the contingent nature of evolutionary history. Our species' current dominance of the planet isn't the inevitable result of inherent superiority, but the outcome of a complex historical process involving both chance and adaptation. The Neanderthals remind us that evolution doesn't have a predetermined direction or goal. It produces diversity, not progress towards some ideal form. This revised understanding of human evolution has practical implications for how we approach conservation and biodiversity today. If human diversity once included multiple species with different adaptations and capabilities, the loss of that diversity represents a significant narrowing of evolutionary possibilities. Our species now stands alone as the only surviving member of our genus, having lost the alternative perspectives and adaptations that other human species represented. This diminished diversity
makes us more vulnerable as a species. If all humans share the same fundamental adaptations and vulnerabilities, we're more susceptible to catastrophic threats that exploit those shared characteristics. The existence of multiple human species, each with different strengths and adaptations, would provide greater resilience against such threats, whether disease, climate change, or other challenges. The Neanderthal story offers a sobering reminder of how quickly a successful, well-established species can disappear when circumstances change. For hundreds of thousands of years, Neanderthals were the dominant human species in Europe. Their robust bodies and sophisticated cultures perfectly adapted to Ice Age conditions. Yet within a few thousand years of modern humans arriving in their territories, an eye blink in evolutionary time, they had vanished as a distinct population. Their fate raises uncomfortable questions about our own species' future. Like the Neanderthals, we've developed highly specialized adaptations to particular environmental and social conditions. Our technology, our social structures, and our ways of life depend on a relatively stable climate and predictable resource availability. As we face accelerating climate change and environmental degradation, the rapid disappearance of the Neanderthals serves as a warning about the potential fragility of even long-established and successful species. But the Neanderthal story isn't just a cautionary tale. It's also a source of hope and expanded possibilities. The evidence for interbreeding between Neanderthals and modern humans challenges simplistic notions of species boundaries and suggests a more fluid, interconnected view of life and evolution. It reminds us that differences don't necessarily preclude meaningful interaction, genetic exchange, and potentially cultural sharing. This perspective has relevance for contemporary discussions about human diversity and identity. If our ancestors could recognize Neanderthals, with their distinctive appearance and separate evolutionary history, as potential mates and social partners, perhaps we can more readily acknowledge the fundamental commonality that underlies the relatively minor variations between modern human populations. The Neanderthal story also expands our conception of what it means to be human. For centuries, Western philosophy and religion positioned humans as categorically distinct from other animals, unique in our cognitive abilities, our moral awareness, our capacity for culture and technological innovation. The discovery that Neanderthals shared many of these supposedly unique human traits suggests a more continuous view of intelligence and complexity across species. This continuity extends in both directions, not just to other human species like Neanderthals, but potentially to non-human animals as well. If Neanderthals, with brains organized somewhat differently than our own, could develop complex cultures, sophisticated technologies, and possibly symbolic expression, perhaps we should be more open to recognizing similar capabilities in other intelligent species like cetaceans, elephants, or great apes, each with their own unique neurological organization adapted to their specific environmental challenges. The recognition that intelligence and complexity can take different forms has implications for how we might approach non-human intelligence in the future, whether through artificial intelligence or potential contact with extraterrestrial beings. Our experience with Neanderthals suggests that we should be cautious about imposing our specific cognitive patterns as the only valid form of intelligence, and be open to recognizing and valuing different expressions of complex thought and behavior. As we continue to uncover new evidence about Neanderthals through archaeological discoveries and advanced analytical techniques, our understanding of these ancient relatives grows ever richer and more nuanced. Each new finding, whether a sophisticated tool, evidence of symbolic behavior, or insights from ancient DNA, adds another piece to the puzzle of who they were and how they lived. Recent technological advances have dramatically accelerated this process. Improvements in DNA extraction and analysis techniques have allowed researchers to recover genetic material from increasingly ancient specimens, including some more than 100,000 years old. These advances have revealed not just the Neanderthal genome, but evidence of other extinct human species like the denisovanos, known almost exclusively from their DNA, rather than physical remains. New dating techniques have provided more precise chronologies for Neanderthal sites, allowing researchers to correlate archaeological evidence with specific climate events and potential interactions with modern humans. Advanced imaging technologies have revealed details of Neanderthal anatomy that weren't visible using traditional methods, from the structure of their inner ears to the development patterns of their teeth and bones. Perhaps most excitingly, researchers are beginning to extract and analyze proteins and other biomolecules from ancient specimens, potentially revealing aspects of Neanderthal biology that aren't recorded in their DNA. Analysis of dental calculus, the hardened plaque on teeth, has provided insights into Neanderthal diet, health, and potential medicinal practices that weren't accessible through traditional archaeological methods. These technological advances promise to continue expanding our understanding of Neanderthals in the coming years. We may soon be able to reconstruct aspects of their sensory experiences, how they perceive their world through sight, smell, and hearing. We might gain insights into currently invisible aspects of their biology, from their gut microbiomes to their hormonal patterns. And we may be able to track changes in their genetic diversity and population structure over time, revealing how they responded to climate fluctuations and other challenges throughout their long history. As our knowledge of Neanderthals grows, so too does our appreciation for who they were, not primitive precursors to modern humans, but sophisticated beings with their own unique adaptations and capabilities. The crude caricatures of hunched, grunting brutes that once dominated popular culture have given way to a much more respectful understanding of Neanderthals as complex, intelligent humans who thrived in challenging environments through a combination of biological and cultural adaptations. This revised understanding is gradually making its way into popular culture as well. Recent depictions of Neanderthals in documentaries, museum exhibits, and even fiction have moved away from the stereotypical caveman image toward more accurate and respectful portrayals that emphasize their humanity and sophistication. These cultural representations matter. They shape public perception and influence how we think about human diversity and evolution. The Neanderthals have also become central to ongoing scientific and philosophical discussions about human origins, species boundaries, and the nature of intelligence. Their story challenges us to reconsider deeply held assumptions about progress, superiority, and what it means to be human. They remind us that our species' current dominance of the planet isn't the inevitable result of inherent superiority, but the outcome of a complex historical process involving both adaptation and chance. The Neanderthals, with their powerful bodies, sophisticated minds, and complex cultural adaptations, represent both a mirror and a window. A mirror reflecting aspects of ourselves that we share with these ancient relatives, and a window into alternative possibilities for being human. Their story isn't just about who they were, but about who we are and who we might have been under different circumstances. As we move forward into an uncertain future, the Neanderthals remind us of both the remarkable adaptability of the human lineage and the potential fragility of even long-established species. They challenge us to reconsider what it means to be human and to recognize the value of diversity, both biological and cultural, in enhancing our collective resilience. Their legacy lives on not just in the DNA many of us carry, but in our expanding conception of humanity and our place in nature. They weren't simply freaks of nature with extraordinary physical strength. They were sophisticated, intelligent beings who represent an alternative expression of humanity. Their story enriches our understanding of what it means to be human and expands our vision of what might be possible for our species in the future. The next time you look in the mirror, remember that for many people, a small but significant portion of what you see reflects the genetic legacy of these remarkable ancient humans. The Neanderthals aren't just a fascinating chapter in our evolutionary past. They're part of who we are today. Their genes and their story woven into the fabric of our biology and our self-understanding. And as we face the complex challenges of the 21st century, from climate change to pandemics, from technological disruption to social transformation, the Neanderthals offer a valuable perspective that combines caution and hope. They caution us about the potential fragility of even successful species when circumstances change rapidly, but they also remind us of the remarkable adaptability of the human lineage and our capacity to thrive in challenging environments through a combination of biological and cultural innovation. Their story continues to unfold as new discoveries reveal more about who they were and how they lived. Each finding adds another piece to the puzzle of our shared human past and expands our understanding of what it means to be human. The Neanderthals, once dismissed as primitive brutes, have emerged as sophisticated, complex beings whose legacy enriches our appreciation of human diversity and possibility. They truly were freaks of nature, not in the dismissive sense that term is sometimes used, but in the sense of being extraordinary, remarkable beings whose physical and cognitive adaptations allowed them to thrive in some of the most challenging environments on Earth. Their story deserves to be told, not as a footnote in human evolution, but as a remarkable chapter in its own right. The tale of another kind of human who walked the earth alongside our ancestors, and whose legacy lives on in our genes and in our growing appreciation for the diversity of human experience. ¿Qué nos enseña esta historia? Nos muestra que la evolución no tiene un único camino y que la fuerza no es la única clave para la supervivencia a largo plazo. ¿Qué piensas tú sobre estos seres increíbles? ¿Te sorprende su inteligencia y su capacidad de crear? ¿Crees que ellos tenían su propia forma de arte y lenguaje? Si este video te ha parecido tan fascinante como a mí, asegúrate de suscribirte al canal, dale a me gusta y deja un comentario para decirme tu opinión sobre esta fascinante especie humana. Tu apoyo es lo que me permite seguir contando estas historias. Nos vemos en el próximo video.